I'm only going to talk about photons and electrons today, but the potential for describing other physical particles is there also. In the electron, the quantum can pass through the speed of light, and because the quantum itself does not have mass, but rather is a carrier of energy, it does have charge. There's no limitation on charge passing through the speed of light. Mass cannot travel, rest mass cannot travel through the speed of light, but charge could travel through the speed of light. Okay. And the quantum can generate a photon or an electron depending on whether the quantum's helical trajectory is open or closed. Open for the photon, closed for the electron. Okay, so the summary. For the photon model, the superluminal quantum model of the photon, the result, which I'm not going to derive today, but I'll be talking about trajectories today. So the trajectory of a superluminal photon is found to be basically think of it, the slinky is describing the trajectory of a helically moving particle. What I found by describing the momentum of a photon as itself moving helically. Okay, so the momentum of the photon has a transverse component, which gives the photon its longitudinal. It gives it the photon its longitudinal momentum given by h over the wavelength, and treat one turn of the helix as a wavelength. And the photon has a transverse component, which contributes to its spin. The photon has a spin of 1 h-bar. Now, if you put that information into the geometry of a helical model, it turns out that the only angle that fits the photon, the longitudinal and the transverse properties, is a helix of radius, the wavelength divided by the square root of 2. That's if you look at this, you can see it looks like a sine wave, but it's a sine wave that has an angle of 1, or a slope of 1, a forward angle of 45 degrees. So the superluminal photon is moving in the helical direction at 45-degree angle with a speed, because of that 45-degree angle, the speed of the superluminal quantum around its helical trajectory is c times the square root of 2. And that result is true for all photons. It's independent of the energy. So a higher energy photon would have a smaller, have a shorter wavelength, and therefore shorter wave radius, but would always have the same shape. The trajectory would always have the same shape. The transluminal quantum model of the electron, okay, if the same helical motion, take one wavelength of a photon, okay, consider that the photon has the energy of an electron. In other words, the energy, rest energy of the electron, as a photon, then the wavelength of that photon is one Compton wavelength. That's the wavelength that gives the photon the same energy as an electron. Take one Compton wavelength, one term of the photon, take that as an axis, the axis of the photon, one Compton wavelength, double that axis around into a double loop and close the axis together, join the trajectory itself, join the slinking itself after the axis has gone through a double loop, adjust the radius of the helix in the way that I'll describe, and you have the model of the electron. Why a double loop? Because if you take a single loop, if you turn a photon, the axis into a single loop, what you get is an object with a spin of 1. So to get a spin 1/2 electron, you have to double it around. That makes the radius smaller. Then when you calculate the spin of the photon of the electron based on half the radius now, the same momentum as the Compton photon, you get calculated the spin of the electron. So it requires a double loop turning of the Compton wavelength to get the photon model. Okay, when you have that model and you adjust the radius, so, and it now becomes, the photon is charged. When it's in an electron moving in a closed double-looped helix, it's a point charge, it's a charge of one electron charge. When it's moving in that double-loop pattern, it turns out that the radius of the helix is set so that the electron has the magnetic moment, known magnetic moment of the Dirac electron, which was modified slightly by quantum electrodynamics, but in terms of the Dirac electron, it was magnetic moment was called the Bohr magneton. If you adjust the radius of the photon, of the rotating photon-like object, which is now the electron, adjust the radius so that that circulating charge creates a magnetic moment equal to the Bohr magneton. It turns out the radius required for the helical motion is the square root of 2 times the radius of the axis of the helix. And when you have that model, the circulating quantum is found to have a minimum speed by the equations, which I can show you later, for the electron. It has a minimum speed of 0.707. That's the square root of 2 divided by 2 times the speed of light. And it has a maximum speed, as it circles around, of 2.515 times the speed of light. So, and it moves, as it moves around this closed trajectory, the frequency at which it moves is about 10 to the 20th times per second, because it's moving at the frequency of the photon that has the Compton wavelength. That's a gamma photon that has that particular frequency. So it oscillates, you can say, although it's not a linear oscillation, from speed 0.707 c to subluminal to superluminal 2.515 c and back. About 10 to the 20 times per second. The electron model turns out to have a number of properties of the Dirac equation, which I'll explain a little bit more detail, but including what's called the jittery motion, or Zitterbewegung, of the electron, which Schrödinger found when analyzing the Dirac equation. That jittery motion has a certain speed of light associated with it. It has a certain amplitude, and it has a certain frequency. And also, the Dirac equation predicted the antiparticle. And all of these things are contained in the electron model as well. So, it's quite a number of properties of the electron model are consistent with the Dirac equation. And one final point, this rotational photon-like object that creates the electron model has a circulating internal momentum. That internal momentum may be associated with the inertia of the electron, and I'll come back to that as well. So here's an image of the photon moving at a 45-degree helical loop, with speed 1.414 times the speed of light. It has angular momentum of 1 h bar. Its charge is 0. The quantum is point-like, both the photon and the electron model, but it has energy and momentum. The energy and momentum are in the photon, or carried by the quantum particle, and everything else is the trajectory. Okay, so the trajectory is the path as it moves through space. Photon model, its parameters, for example, the photon has energy h bar omega that corresponds to the angular frequency of the quantum of omega. The momentum of the photon corresponds to the pitch of the helix, called that lambda, the wavelength. The spin of the photon is found to be correct if the radius of the helix is set for lambda over 2 pi. The polarization of a photon, which is left or right, corresponds to the helicity of the helix, which can be left or right. The speed of the photon in a vacuum. C corresponds to the longitudinal component of the photon model. So all of the parameters of the photon are built into the photon model. Now here's a photo of a construction of my electron model. It is colored for a reason. I've got a physical model you can see sort of in outline, but it's a particular three-dimensional structure. Again, the wire is the trajectory of the quantum, which is just, you can see the ball on the wire, and there it is up there. Ball on the wire is the quantum. This is a closed, double-looped helical path. Now, the red and the blue correspond to the blue corresponds to the subluminal motion of the quantum along its helical path. The transition point from blue to red is from subluminal to superluminal. The red is the superluminal portion, which increases to a maximum speed. I mentioned 2.515 times the speed of light, and it slows down, goes subluminal, and reaches its minimum speed at the z-axis of 0.707, increases its speed slightly, decreases again, and then again takes off. So imagine this B moving around this closed double-loop helical path 20 times, 10 to the 20th times per second, and that will give you a kind of image of what the transluminal electron model is. Dirac, with his relativistic electron equation, his electron had a number of spatial properties as well as kind of general properties. Dirac assumed that the electron was a point particle. And in fact, experimentally, high-energy scattering experiments, electron-electron scattering experiments, have shown that the electron acts like a point particle with radius less than 10 to the minus 18 meters. So it really looks very point-like. And Dirac had assumed that as well in his model. He built his equation, his relativistic equation for the electron, based on the energy-momentum relation for a particle with rest mass. That's a standard equation. The Dirac equation predicts the spin 1/2 h-bar of the electron. It gives the correct electron magnetic moment, pre-QED, h-bar of 2m, and the jittery motion, which has a frequency of twice the frequency corresponding to that, the Compton wavelength. In other words, twice that frequency. It's sort of surprising. Why twice the frequency? If the okay, it was a result from the Dirac equation. The amplitude also 1/2 of the number related to the Compton wavelength. That h-bar is there actually because you can consider that value the radius of that, in terms of the model, the radius of the double looped axis of the in the model corresponds to that amplitude of the Dirac equation, and the speed of the electron from the Dirac equation is the speed of light. Okay. The model predicts the electron's antiparticle, and the electron model predicts it as well, because if you take a mirror image of the electron model, you get the mirror image of that could be the positron. So the model includes the positron as well, and the electron, in Dirac's electron, has a periodicity of 4 pi, which is sort of unexplained normally, but the double-looped helix model of the electron gives it a periodicity of 4 pi also. So the electron model has mass energy. Its Compton wavelength corresponds to that, and the frequency, mc squared over h. The charge of the electron minus e are comparable. The spin 1/2 h-bar. The radius of the helix is 1/2 that quantity related to the Compton wavelength. The magnetic moment is determined by this factor square root of 2 related to the Compton wavelength, and the helicity is related. Here are a couple of views of the quantum model. The maximum speed is out here. The minimum speed, as I mentioned, is there. sorry, I moved back. Okay. A few views in color. Again, the red is the superluminal, blue is subluminal. The superluminal distance of the quantum turns out to be 76% of the trajectory, whereas the subluminal distance, 24% of the trajectory. That's derived from geometrical factors of the model itself. The time spent superluminally is 57% of its trajectory time, and subluminal 43%. Here's the velocity, or rather say speed, of the quantum along its trajectory in its 4 pi angular rotation. Here's the 2.5 times the speed of light. Here's 0.707. I've also got the acceleration of the electron along its path. That's the green line. Notice the maximum acceleration is when it's in the superluminal range, both going into and coming out of superluminal range. Notice that the acceleration, the units of the acceleration are around 10 to the 29th meters per second squared. That's about 10 to the 28th times the acceleration of gravity. The reason that acceleration is so large is because every cycle you go from less than the speed of light to almost 2.5 times the speed of light. The change in speed divided by the time change for that speed to take place, is huge. And it gives you that very large acceleration. You can calculate the jerk of the motion, which is the first derivative of the acceleration, and you can go to higher derivatives as well. One final note, the inertia of the electron model, because the circular internal motion has momentum pc, the relativistic equation is this. Now, you can rewrite that relativistic equation as this is external momentum plus the mc squared, which is the internal circulating momentum. That's like an internal momentum of a resting electron. So the electron at rest has an internal momentum, which that may actually be related to the inertia of the electron. It's a sort of a suggestion. Since the electron is like a say a right circulating photon, though closed, scattering of a right polarized electron, right polarized photon from the electron model, you would predict that it would have probably a different scattering relationship than scattering a left circularly polarized photon from the same model. So that's a prediction of the model. Also, the model might be tested by comparing its prediction of superluminal to subluminal portion of its trajectory with experimental data that may not be so easily explained, to try to connect the two together. So, in conclusion, the model has both experimental and theoretical properties of the electron photon built into it. The internal structure is 3D. It can be visualized, which Dirac's equation, he didn't give a visualizable model of the electron, and it can be tested. And one interesting result is the momentum position relationships of the photon and the electron lie at the level or beneath the level of the Heisenberg uncertainty principle. So that, and it's a very precise relationship, so that's an interesting result as well. The model can suggest further trying explanations of elementary particles besides the electron and photon. Some elementary structures could be investigated. Energy can be understood in that way. Entanglement, because of the faster than light property, could be looked at in a different way. Faster than light communication could be possible because of the superluminal speed. Transport could be related to the electron. It has its superluminal internal motion, and the travel for human beings, again, it's speculation, but if the mass has the property internally of superluminality, maybe that can be figured out how to make it superluminal for people as well. Thank you very much. Do you have any questions? Yes?
I guess maybe I'm just thick or something like that, but I don't see how you're going to accelerate the electron to super light speeds and then deaccelerated. If anything, the gravity well, the gravitational, not the gravitational, the charge effect from the nucleus is stronger the closer you're there, and it's weakest when you're further away. And yet, your model suggests that where the attraction is weakest, you accelerate to light speed.
This is all happening within the electron at rest itself. So the electron itself is not accelerating at the speed of light as a whole. Internally, that movement is going on. So that's different. It's like this is the velocity 0. Its average velocity is 0.
Well, the average velocity is 0 right near where the coordinate, the x's are. It's probably a maximum way out there to go straight out to the right. No.
Yeah, the velocity, but the velocity of the quantum is not the same as the velocity of the electron. The electron is basically the average velocity of the quantum. So the mass of the electron is also like the average, the average structure,
the internal structure of the electron.
So we're looking at the internal structure of the electron.
This is the particle that makes up the electron.
Well,
this isn't the electron.
Does that particle travel with the electron?
It is the electron.
Yeah.
That particle is the electron. Yes.
Yeah,
and
so
it's an electron at rest when it is in this configuration. If the electron is moving, then it would be more like traveling in an open loop. It wouldn't close because the electron would have moved sideways.
You're saying it's at absolute 0, something like that? Absolute
When the speed of the electron is 0, it still has all this internal motion that I'm describing.
Oh, I'm sorry, Tim?
Oh, sorry.
You and then Mark.
Well, I'll make mine really quick. So to elaborate on Paul's question, would it be kind of a comparison to say that the internal motion is like the rotation of the Earth, and then what he was referring to would be its orbit around the sun, right? And that would be why the same forces wouldn't necessarily apply?
Well, yeah, the spin of the electron is created totally by this internal circulating motion. So any external motion would create an angular momentum of the electron as an external moving object.
Yeah, so I see how you did your comparison between the Dirac model and this model, and I'm wondering the other parameters of, say, how an electron would absorb a photon and the quantum absorption and quantum release of photons. How does that stack up between the classical, descriptions and
well, this model has a particular energy associated with it, but it could absorb an a photon, and take on that additional energy. What would happen is that its size would shrink a little bit. In other words, having now greater energy, it would have a smaller internal wavelength, and it could then give up a photon in the same way and go back to its original.
But is this model consistent with the known quantum states of the electron?
This is a free electron, so I'm assuming that all of the aspects of a bound electron are the same as the Dirac equation gives. This is the internal structure of a free electron, which that internal structure, because an electron which is not free still has a spin.
Right.
So it would still have some of that similar internal motion even in an atom.
Thank you.
Thank you.
There are a number of questions about this which are raised, of course. That is that you've got the same quantum responsible for a charged and an uncharged elementary particle.
Yes, and yes.
And a massy and a massless elementary particle to boot. And so, in a sense, you're generating the qualities of charge and mass ab initio, right? De novo, in a sense. That's one thing. Other thing is that the trajectory is not a perfect spherical or circular symmetry. I'd be interested to know how you deal with the resultant centrifugal forces that such a closed trajectory would generate, because of conservation issues. Same thing goes for linear considerations, that the trajectory is only 20-something% subluminal. That would be all you would see should you be able to sample at 10 to the 20 times per second, and you wouldn't be able to perceive, would you not, the superluminal, which means that what you'd see would be a fraction of the trajectory, which would look non-concerning.
Well, because the model itself, the relationship of the position and momentum, if you treat them as standard errors and multiply them together, you find out, when you compare that result to the Heisenberg uncertainty principle, that the position momentum relationship is beneath the level of the Heisenberg uncertainty principle. So you can't really, all you will ever detect is you'll only detect the quantum, and you won't know if it was superluminal or subluminal.
Just like your animation. We have time for one more question. Yep.
Thank you.
Yes. How would you model the hydrogen atom? This is technical French. Hydrogen atom.
Well, I'm assuming that all the quantum mechanics, isn't changed by this structure. This structure is, proposing what the internal energy of the electron looks like, but the electron will still have all of the same external energy levels as it would otherwise. I'm going to show you just a quick.
I think one of the next things on the to-do list, if I'm right, Richard, is to model a proton in the same way, as well as some other.
A proton being made of 3 quarks would be harder to model than a quark itself. The quark obeys the Dirac equation just like an electron. Here is an animation of the quantum moving around the path proportional to its actual velocity, slower in the blue area, faster in the red area, reaching a maximum at the red area. And that you can also sort of see from some different angles.
And last question.
Okay. I saw simulations of the Dirac solutions. Yeah. And if someone comes and throws away the first dimension and it looks like your solution, what would you say?
If someone showed that the Dirac equation looked like my solution,
without your solution,
I would be very pleased. Because the properties of this quantitatively match the electron's properties in the Dirac equation. So this isn't 100% of an explanation of the electron, because the electron, its spin is uncertain. Even the direction of the spin is uncertain. So I'm not trying to say that this solves all the quantum uncertainty problems of the electron, but it does give a visibility to the electron.
What I wanted to say is this model is very restricted. In the Dirac equation, the electron has probably more fission.
Well, this is the electron at rest. So if the electron is moving, whatever motion of the electron we have, you can say it's the center of mass. The Dirac equation describes the center of mass motion of the electron, and in addition, this jittery motion. And those are like 2 combined motions in the Dirac solution. So this is only the internal motion, and to that can be added any linear external motion of the electron.
Why don't we save any further questions for after the session? We have one more paper, but let's thank you.